So another pretty short, I'll do a short lecture today, going over a couple papers and then doing some additional work on the board. Just some different combinations of things we've already talked about with discrimination, differences in quality of players, and adding in a little bit of a wrinkle um, that we hadn't really talked about before, but that might help with part of the homework. So I updated the slides on Canvas. So the week 12, you had them already open from yesterday, or you were still looking at, or kind of downloaded them like, I don't know, 5 minutes ago. Re-download them, look at the new ones. I added in some additional slides. So yesterday we left off with this hot-handed sports betting, looking at that paper. So today I've got two other papers I want to go through, kind of just some more interpretation of coefficients from regressions, and then we'll go over a couple more examples on the board. So pretty short lecture today, but just want to get a little bit of material out there. So today we're going to talk about two papers that are related to peer effects. So the first one is steroid use and what they call the Jose Canseco effect, right? So what are peer effects? Peer effects are essentially the influence that an individual's peer group has on their behaviors. So we can look at this in a variety of different ways. Most of the peer effect literature has to do with like how friend groups impact the smoking behaviors, obesity, all these other measures, or how an individual's classmates impact their academic performance is another one of the major areas in which people have researched peer effects. But there is kind of an area within sports economics where we look at peer effects as well. And this one specifically is focusing on the behavior of do individuals use steroids or not. So this isn't going to be the traditional approach of most peer effect papers, but it is an interesting, I think it's a pretty interesting paper, and so we'll go through it. So their main question is, were teammates who play with Jose Canseco more likely to use steroids after they played with him? So, were they more likely to use? Well, they don't actually have data on whether or not individuals were using, especially prior to 2003 when there was no testing. So instead of looking at actual use, the only data they have is the performance, right? So did certain players see boosts in their performance after playing with Jose Canseco? And they would maybe attribute this to that, not that they learned some new batting skill from Jose Canseco, but that maybe that he introduced them to steroid use. So we'll look at see if there's some evidence of that. So their main kind of two variables they're going to focus on is, and these performance measures, they have a bunch of different Y or dependent variables. So these performance measures would be things like home runs, batting percentage, strikeouts, a bunch of different performance measures. And then they're going to say, okay, how does currently playing with Jose Canseco, if this is, I'm currently on his team in this time period T year, then this is a 1. If I'm currently not on the same team as him, then this is a 0. So if I'm currently playing with Jose Canseco, what happened to my performance? And then another coefficient which represents, here this is a 1 if it's after a time period in which I play with Jose Canseco, 0 if it's if it's not a time period after I've played with him. So this is a 1-0 variable as well, which means really this is relative to what? Well, these two would be relative to being in a year where I was not currently playing with Jose Canseco and I'd never played with Jose Canseco. That's the kind of the group we left out. So we've got controls for what kind of the average performance in the league was that year, so kind of time fixed effects. We've got a bunch of other controls for a different batter, like what their previous performance was, and so we're trying to control for all these other factors so that we're really just getting the holding constant, all these other factors, that these two players who looked otherwise identical, but one of them is in a year after they played with Jose Canseco, the other's not, what would the impact be on their performance, right? And if there's a positive effect, maybe we attribute this to not that they're learning skills after they play with Jose Canseco, but this is now in a time period in which they've been introduced to steroids and are now using them. Okay, so kind of the motivator. If we just look at averages, no regression yet, but let's look at just the home runs on average for power hitters from 95 to 2000. For those who never played with Canseco, those who were on the same team as him currently, and then those who after playing with him. Notice currently playing with him increases the numbers up, or they had a higher average, and then after playing with him had an even higher average. Right, but this could just be coincidence. It could be that the teams that Jose Canseco played on were more likely to target power hitters, and maybe that was their strategy. And so, maybe these numbers are skewed. So we can start to control for other things to account for this. So not only do they include kind of time fixed effects, they also include individual player fixed effects. So for every single player, they created a dummy variable that was a 1 if, say, the player was Sammy Sosa, and a 0 if not. So you're essentially controlling for the all other factors for an individual that you don't have data on. That's what those fixed effects would capture, right? That indicator for Sammy Sosa captures anything about Sammy Sosa that would impact his performance that's different from other players. And so we're now able to kind of hold constant even the batter we're looking at, also the year in which we're looking at, and then they had some additional control variables as well. I forget exactly what all of them are. We could manage the manager's winning percentage, so all these different things. There were just really additional controls to make sure we're comparing apples to apples. So if we do that and we look at, okay, what is the effect of currently playing with Jose Canseco on some of these other performance measures, currently playing with, it doesn't look like there's many effects here. And this is on all players except for pitchers. In fact, it looks like maybe on strikeouts he even has a slightly negative impact, right? There's fewer strikeouts if you're currently playing with him, but I don't know if that would be necessarily a result of steroids. And so maybe this is kind of, there was some skills that were being learned from him potentially. But notice that the real interesting one is after somebody played with him, right? Potentially after, the years after they were introduced to Canseco and potentially steroids. They have an off season now maybe to use them. Notice the performance measures of RBIs, strikeouts, and home runs all go up, right? So the idea that they become more of power hitters because they've used steroids, put on the additional weight. They're not only hitting more home runs, but they're also maybe swinging for the fences. They're more likely to strike out as well, right? This is not a good effect. The effect of playing after a year after you play with Canseco, you're more likely to have 3 kind of strikeouts, right? And I believe this is even within a game, I think. Yeah, they're looking at game by game. Let's go back here. No, it must be year by year. So I think this was strikeouts per game somehow. And this must be RBIs per game, yeah. So kind of, pretty side. This must be over the year. So you're more likely to have 1 more home run, 3 more strikeouts, 3 more RBIs, and your batting average will be a little bit higher, right? And those are the only ones that are significant. So, actually, almost significant here. You're a little more likely to have additional walk and a half each year. Okay, so not real large effects in terms of magnitude, but statistically significant effects. Right? Now, if we then kind of go to looking at the effects on power hitters, right? Just power hitters, not kind of factoring in all the other, kind of non-power hitters. And I forget, they define power hitters by previous performance in terms of home runs, or maybe I think it was also by on base percentage or something. Not on base percentage, OPS was the one that they used. So for just those power hitters, after playing with Canseco, they're more likely to get 2 more home runs as opposed to just under 1. Well, almost 6 more strikeouts, 5 more RBIs, and are more likely to get walked, right? Maybe because of the threat now that they are more of a power hitter, right? So it looks like he's having pretty strong impacts. And notice the interesting thing is batting average really isn't changing, and potentially the use of steroids is not going to impact your batting average as much, but when you do hit the ball, right? Because it's not teaching you the skill of hitting the ball, it's just making when you hit the ball have a larger impact, right? So it's kind of interesting. We then look at what the effects are on power players, right? So this is kind of larger. Here was, I forget the exact difference between power hitters and power. I'll have to go back in the paper. We'll pull the paper up here in a second to look at this. There was some difference between how they define power players and power hitters, but once again, looks like maybe there's not as strong an effect on things like steals or fielding percentage, which we wouldn't expect there to be, but those players are more likely to play more games, get more at bats, and hit more home runs, right? So it's kind of interesting as well to see that they're getting more opportunities, but also that some of these things that we think might not be as impacted by steroid use aren't really changing either. Okay? I think kind of the final thing they look at is, well, look, what's the effect that he was having on power hitters? Was there any effect coming from other players, right? And even some of these other players that maybe had been known to use steroids, but Jose Canseco kind of being the one who self-proclaimed, or a lot of other players kind of gave evidence that he was the one sharing. But even some of these other players that we know have used, like Palmeiro, Giambi, McGuire, were they sharing? Because if they were sharing, we should see positive effects from them as well. Well, in fact, some of them have negative effects, kind of like Griffey, Palmeiro has and some of these guys have no impact. Really, if we look at any of these other power hitters, some of them known to use, some of them known to not use, there was no real positive effect coming from any of them on home runs or even at bats, except for Jose Canseco. All right, so isn't perfect evidence, but maybe some stronger, pretty good evidence that maybe, right, he was introducing players to these steroids that were then more likely to use and more likely to see an increase in these power performance measures. The paper then, kind of for additional evidence, says, well, look, after 2003, we know that the league started to, enact testing. So let's look at this in two different time periods. What was the effect that after playing with Jose Canseco was in the time periods before 2003, and what was the additional impact after 2003? Right? So what they did was and kind of this is our initial, if we didn't kind of include this additional interaction term, this was what was coming from, where was it? Where did this come from? This is its own regression that they ran and got kind of the effect that he was having on RBIs, strikeouts, and home runs. If we then look at what was the effect after playing with him, but we also include this additional interaction term with, well, what was the effect after playing with him if I was in a time period that was after 2003? So now, if it's after a time period in which I played with him, this would be the effect. But if the time period was after 2003, I would have to then add this in as well. So for the years prior to 2003, this would be the effect of on performance of after playing with Jose Canseco. So notice that number is actually higher than our previous estimates. Looks like he had even more of an effect on home runs, strikeouts, and RBIs, and maybe even batting average. But post 2003, if I played with Jose Canseco, well, it was a year after I played with Jose Canseco, so this was a 1, so here's the effect. But it's this effect plus, if it's past 2003, plus this. So the total effect of playing with Jose Canseco would be the sum of these two. Now notice if I add these together, these are really close to 0. And in fact, these are, if I kind of test for whether or not when I add these together, if they're different from 0, and none of these p-values are small, right? So this statistically was no different from 0 because they kind of cancel each other out. This about cancels each other out. We can't say that it's statistically different from 0 because the p-value is much larger than alphas of 0.01, 0.05, and 0.1. And really any of these, we can't say there was any difference in the performance measures after playing with Jose Canseco if it wasn't a time period after 2003 in which the league was testing, right? Testing for steroids. So really this effect was being driven by the years prior to testing. So another stronger evidence that maybe this increase in performance really was coming from the ability to not only learn how to use steroids, but to also be able to use them without being tested. Right? So pretty interesting, strong evidence. Okay. The next paper I want to talk about, and also this will be the paper. I'll put this up. It's up in the weekly. It's already up in the weekly readings. This is the one that for the weekly quiz I would be asking a question about this paper. Okay. So the next one we're going to talk about is pure effects in performance, specifically swimming performance. And so the idea is that if I'm swimming against better swimmers in my meet or in that heat of the meet, do I perform better, right? So this is kind of like the idea we talked about a long time ago when the little kids running against each other. if I'm running next to someone who's better, maybe I run a little bit faster. So if I'm swimming with people who are better, maybe I swim a little bit faster in that heat. So the measurement of performance is going to be how long did it take these swimmers to complete whatever the distance of their of that particular swim, I don't know what you call it, that race was, right? So what was the impact on how long it took them to complete their race? And then what was the effect of if the average time of all other, so when it says negative j, t minus 1, it's basically the average time of all other swimmers other than them that are in that heat. So if the average time of other swimmers goes down, right, so they're better, then we would expect that that would have a negative, if that's a larger negative value. So if that goes up, so the average time goes up, there it gets slower. So yeah, we would expect this to be positive, right? Think about doing it in reverse. If the average time of all their swimmers goes up, we would expect the time of the current swimmer to also go up. They're not going to try, they don't have to try as hard to win. And so if the average time goes up by 1 unit, we would expect this to be positive, that if the swimmers are worse, I perform a little bit worse. If the swimmers get better, and this is actually negative, negative times a positive would predict that the time of the current of the swimmer looking at also goes down. And then here they also look at not only if the average time, but what if the standard deviation changes, right? What if the swimmers in my heat, if there's a lot more variation, right? If there's more variation, does that increase or decrease my time as well? And also, I stole this right from the paper, so this should be beta 2. They had a little bit of a typo in there, but that should be beta 2, and this is beta 1. Okay. All right, so here's their kind of results, which would be that as the average time, right, of all other swimmers in my heat goes up, I also would swim a little bit slower, right? If they get a little bit slower, I get a little bit slower. In fact, if on average the other swimmers go kind of up in their average time of 1 second, I would swim 0.3 seconds slower as well, right? Or it would take me 0.36 seconds longer to complete that race. Standard deviation, if the variation in the swimmers goes up, then I would actually expect maybe to see my time go down. So holding constant the average, if we have a wider distribution, essentially, if we had a wider distribution, remember, when we interpret regression results, what we're saying is holding everything else constant. So because we have a control for what the average time of all the other swimmers were, it's basically like saying, well, look, if I've got one heat, and here's the average time, and here's its standard deviation, let's say is 10. Well, if the standard deviation goes up, right, there's more variation in the data, what we're really saying is that that distribution flattens out, but we're holding constant that mean. So now, with that same mean, but a higher standard deviation, now it's more likely that there's kind of people on either end of the distribution, so it's more likely that there's a really, really fast swimmers and some really, really slow swimmers. And so what the regression results said was that if, in fact, we see the standard deviation go up, we would expect the swimmer's time to go down. And this is maybe because even though the average is the same, there's more likely to be some really good swimmers that help push up the performance of the swimmers, the other swimmers in the heat that they're in, right? So that's kind of what we get from our regression results there. Pretty interesting findings, and if you look at the actual paper, they have some stuff that we don't really have time to cover. That's a little bit even stronger of evidence, right? So I just showed you this first column. They have some other stuff they do, like a Heckman selection model, which really finds similar effects, so that there is this strong positive effect coming from the average time and somewhat of a negative effect coming from the standard deviation at that time. So both kind of strong evidence that, and they're holding constant a lot of things like age, height, weight, gender, whether or not the meet was in the finals, if it was prelims, year, and kind of race type fix effects. So they're getting everything in there. And still finding that there is some evidence of peer effects. Also, I'm going to lose my mind. You're going to hear all these horns because my neighbor decided that, and I guess it was a nice thing, but it's their daughter's birthday, and so they put up a sign that said honk for whatever her name's birthday. So that's why you hear the horns going on. Okay, Got that off my chest. So those are kind of the two papers I wanted to cover today on peer effects. You see this a lot in economic literature, but here we have some specific examples in sport. Okay. So I wanted to walk through a couple things on the board as well. Somewhere what we did last class. Okay, so I got my webcam pulled up. I'm going to also pull this up. So I don't think we have anyone watching right now. So I'm essentially talking to myself. But this will still be a good recording here. Okay. So last class, what we did is we looked at differences of kind of the large and small market, and I just dropped markers all over the floor. Large and small market, and so here we go. Let's see if I can get my webcam to autofocus here. Sometimes if I switch on and off there, maybe a little bit. So we talked kind of mainly the effects of large and small markets. So let's do one today where, let's say, we've got this labor market, right? Got my wages. So this one might help a little bit with the homework. So let's say I've got supply of labor here. Okay. And let's say this is for a school like, let's do Ball State. Right? Now, we're going to put this in the context of college. Now, obviously, college players don't get paid, but this allows us to understand what would happen if they did get paid. And we can think about this. I'll make a kind of professional sport analogy once we're done. So here's the supply of labor at Ball State. And let's say that Ball State's football program earns similar revenues as maybe, well, who could I maybe imagine that they had similar revenues to? Let's say like, I don't know, like a Harvard, right? Harvard's not really well known for football. I'm sure, any given year they do have some, they do generate some revenue. Or maybe like you want a better example, maybe you think is like Army or Navy, where they're, well, Navy's maybe a little more competitive. But Army doesn't win a ton of games, doesn't get a lot of national exposure, but the benefit, so what we're going to assume is that like the marginal revenue per win, and this might not be true, but for the sake of my example, let's assume the marginal revenue per win from Ball State is similar to Harvard when it comes to football, or Yale. Choose your Ivy League school. Right? Well, the supply curve for labor at Ball State, that's kind of factoring in what wage they would get paid there if we allow them to be paid. Right? But at Harvard, if I was getting paid the same wage, I would actually be willing to supply even more labor, because I'm not only getting that wage, I'm getting that wage plus the additional benefit of whatever that degree is worth to me, right? And so if we think about factoring in the degree and how much the degree is worth, well, the degree is worth more from Harvard than it is from Ball State, assuming it's the same major, right? So we can kind of think about this two different ways. To get the same amount of labor, Harvard would have to pay not a higher wage, they would actually have to pay a lower wage, right? To get the same quantity of labor, they would pay a lower wage. So the supply curve for labor at Harvard is actually going to be kind of higher, right? Or at the same wage, there'd be more people willing to play for Harvard than there would be for Ball State, right? It makes sense, because if they get the same wage, well, at Harvard they're getting that wage, but also some additional benefit of the degree. And so if we think about where these equilibrium points are going to be, so this was just to kind of help understand why the supply curve was higher there or greater. Now if we kind of think about what would the equilibrium wages be, well, at Ball State, to get that same play, they're going to have to pay kind of higher wages, right? Kind of the equilibrium wages would be higher, or even if you think about to get the same quantity of labor, they're going to have to pay a higher wage as well, because they don't have this additional benefit to the player, which is the degree of the value of the degree. Okay, So we can start to think about that. Now, I did this for Ball State Harvard, and if we had allowed colleges to pay players, very easy analogy would be if instead, let's say I do something like endorsement deals, and maybe we think about the marginal revenue per win. Maybe it's very similar. So instead of Ball State and Harvard, maybe it's very similar between LA and New York, but maybe the like endorsement and then how much I can be involved in maybe television or films, maybe that's higher in LA. So the marginal revenue per win looks similar from basketball, but there's this additional benefit, which is the money I'll be making outside of basketball. So maybe kind of LA, if I'm being paid the same wage, I'll supply a little bit more labor, or to supply the same amount of labor, I would require a lower wage in LA because there's all these additional benefits to me as well. So instead of Ball State Harvard, we could think about this as maybe LA New York. I think it's a good example because those marginal revenues per win would be similar. They're both large cities, large populaces, but there might be some additional benefits of being in LA as opposed to New York, right? So that would kind of push that supply curve up a little bit from that one player. Right? So that's kind of a good example there. The next one that I want to do, like I said, I didn't see anyone live viewing, so if there's any questions, please feel free to chat, type in the chat, but otherwise I'm going to kind of assume that no one's watching this and kind of record. So, or watching it live. Hopefully you're all kind of getting on later. So what's another thing that we could think about? Let's say I've got quantity of labor, I've got wages up here. Right? Let's assume for a second that we were going to have the supply curve for labor, so we're going to start out kind of here. Right? So let's assume, right, that I've got, this is the demand curve for labor from a low quality player, and then I also have the demand curve for labor for a high quality player, right? And let's assume this is the same team, right? I'm looking at the same team. Here's a high quality player, low quality. So my demand curve for labor, I'm looking at the same team, so that marginal revenue per win is held constant, but because it's a higher quality player, that drives up this marginal wins per labor, and that's why we have a higher demand curve for labor for the high quality player. Let's say they'll both kind of supply their labor at the same rate, so their supply curve is the same. They'll take the same wage for the same units of labor, the same kind of what we said quality labor hours or quality units of labor. So we kind of see here, obviously the team would be willing to pay the high quality player higher wages than the low quality player. Right? But what if that high quality player, right, is discriminating, right? Such that in order to play on this team, in which there's, whether to make this a black, white, a foreign, domestic, whatever groups we want to choose, that this employee, right, is discriminating. So we said when there's an employee discrimination, right, it's operating through kind of this supply curve. So this was the supply curve, and we can think about this as a, now that's where we start out. Now this is if it's, we'll say ND for non-discriminating. But the supply curve for a discriminating employee means that to get the same amount of labor from them, you'd have to give them a higher wage because there's an additional cost to them, which is playing with this group of people they don't like. And so I want to make sure I get this, here we go. So if we kind of look at something like this, right, this is the supply curve that's coming from that discriminating employee. Now, if the discriminating employee are only the kind of high quality, then the wage they would kind of want is way up here, right? And so the teams look at this, right, and say, well, look, if this is a discriminating employee, we're willing to pay a much higher wage. They're still bringing in, right? The demand curve for labor shows us how value they're adding to the team, and so they're willing to pay them this higher wage to get this higher quantity of labor. And so they can kind of force their wages up even higher, if this is in fact the case, right? So this is kind of how employee discrimination would work. And if you have high quality players who are discriminating, those teams might be willing to pay them these kind of higher wages because they are bringing such a high value to the team. Now, if we think about this instead of like a individual player level, what's also going to be true is that these teams, if this is like the high quality players that we can kind of break players into high quality, low quality, yeah, they'll be willing to pay them these higher wages, but what's going to happen to the number of high quality players that they can carry on the team? Well, it's actually going to go down, right? And so what's interesting is because these employees are discriminating, there's going to be few higher quality employees or high quality players who are hired, right? The quantity is going to go down. Now, if they keep their job, they're going to get these higher wages to play on these teams with these individuals they don't like, but their discrimination caused some of them to kind of lose their jobs, right? While as the non-discriminating kind of low quality, there's no change, right? So that's kind of an interesting combination of kind of high, low quality players, some employee discrimination, and kind of the effects that we would see there. Okay. And I wanted to draw something that I'm not sure that I got at when I was going through it in the lecture. So let's go to kind of this world where, what if we allowed schools to pay student athletes, right? And so let's go quantity of labor, and we've got wages up here. So let's say we've got a supply curve for labor, and let's just for the sake of argument say that it's going to be the same regardless of the school we're looking at. So let's just assume for a second the supply curve for labor is going to be the same. If we had, what two examples can I use? I'll do the demand curve for labor. Let's do Ball State, and let's do, I don't know, I like Purdue, so let's do from Purdue. And if you don't think the supply curve for labor will be the same between the two, that's fine. But if we're thinking about just the wages here, and so if there is maybe some value to a Purdue degree that you wouldn't get from Ball State, then we could talk about supply curve differences as well. But I'll make an even easier assumption. Let's say this is for a general studies degree. I don't know. There might be a difference in a general studies degree from Ball State versus Purdue, but I'm going to tell you it's not going to be very much. So let's say we've assumed away that. And really that this is driven by this difference in the demand curve. We're looking at the same player or same type of players, so that differences in the demand curve between the two is really going to be driven by Purdue's marginal revenue per win might be a little bit higher. And maybe this isn't, I don't know, maybe this isn't the basketball or a football team, maybe this is the basketball team, right? That way you could probably argue Purdue has the higher marginal revenue per win. I don't know if it's true about their football program right now. So we would expect to see kind of higher wages up here, equilibrium wages at Purdue as opposed to Ball State. Okay? Now, if I allow schools to choose between offering wages or offering their tuition, well, let's say these wages that I'm coming up with would be like an annual salary or an annual stipend that they're giving to their players. Let's say that Ball State's tuition, so let's say the equilibrium wage somehow ends up being, I probably should know these numbers off the top of my head, but I'll choose some to make it easier. So let's say this wage ends up being $5,000. Let's say this ends up being $10,000. Right? If the value of tuition over that year was something like, I don't know, we're not going to make these numbers realistic, but let's say it was $6,000. Right? Well, the value of offering a scholarship is actually greater than if I paid them those wages of $5,000. And so as Ball State, I might choose just to give them that tuition remission because the value to that player is greater. Right? Also, we talked about really the cost to the team. If that doesn't displace another student, or that that student wouldn't have went there anyways and paid the money, then this is really a zero cost. Right? Now, what about for Purdue? Well, let's say their tuition, they've kind of put a freeze on it, and so it's relatively low. I think it's actually, this might be per semester, so maybe we're doing this by semester as opposed to annually. Let's say it's like at 7,000. Well, they look at this and say, well, look, if we offer a tuition remission instead of paying the wage, that's going to be below the equilibrium. We're not going to be able to kind of get to this equilibrium point by only offering this tuition remission, so we're going to be paying kind of that wage of 10,000, right? If I in fact only offered this tuition, I'm only going to get kind of a smaller number of players, like a fewer number of players, right? Because at 7,000, only people below this point would be willing to work for that much. Also, if I offered just the option, these players, if they're rational, should always choose the wages at Purdue instead of the tuition remission, but at Ball State, they should always choose the tuition remission instead of the wages. Now, those tuition remissions aren't like liquid cash, but in terms of the actual value to the individual, they would be higher at Ball State than they would be at Purdue. So this is when we can start to think about if we gave not only schools, but maybe the players the choice between a tuition remission or whatever the equilibrium wage that the university was willing to pay, kind of how that would look. Okay. All right. So that's really all I wanted to do today. I know the lectures were a little bit shorter this week. I'm probably going to kind of still go through a lot more papers next week and maybe bring in some additional models that we can think about for the labor market, maybe a little bit more complex, maybe working in some expected value. But hopefully a lot of you are starting to transition working your projects. So I mentioned in yesterday's recording, I should be getting all of those data sent out today. The data sets sent out tomorrow and Thursday. I should have all of them done by Thursday. I'll probably do a little bit more next week too about how you go about your lit review. I've showed you a little bit with Google Scholar in the past, but just some more practice with that. And if you start to have any questions as you're working through the data, please email me and I'll try to kind of maybe build some of that into lectures as well, showing people how to do things in Excel that are common questions that people have. So please reach out, ask me questions as you're working through that project. Other than that, short recording for today, and we'll see you next week.